You are looking at a piece of iron that could be well over 100 years old and still doing its job. That is not unusual on farms that have kept working the same hand tools for generations in Lancaster County and elsewhere. What you're about to learn is the same treatment that museums and conservation labs use today to keep historic iron artifacts from crumbling into rust. And the active ingredient at the center of it costs about $3 to $5 at any grocery or supplement store in America. Before we get there, hold on to one question. Why does a rusted-out tool from a modern hardware store often get thrown away within a decade, while iron tools maintained the traditional way can still be working a century later? Here is what most rust guides never explain clearly. Rust is not the end of the metal. Rust is iron oxide. The iron atoms are still there. They have simply bonded with oxygen instead of staying pure. The reason ordinary rust removal fails over and over is that it treats rust as something to scrape away. Sand it off, grind it down, wire brush it back to bare metal, coat the bare surface, and wait for the cycle to start again. There is a different approach, and it is not folklore. It is documented chemistry. When tannic acid contacts iron oxide, it reacts with the iron ions in the rust and forms a new compound called ferric tannate. Ferric tannate is dark blue-black, largely insoluble in water, and chemically bonded to the iron surface. It does not sit on top of the rust and eventually flake away. It converts the rust itself into a stable, protective layer. This is exactly the process described by the Canadian Conservation Institute, a federal Canadian government body, in its published conservation notes on iron artifacts, CCI notes 9.5 and 9.6. Their documentation states that applying tannic acid to rusted iron produces a uniform blue-black finish, reacting with the corrosion layer to form ferric tannate, which helps protect the most vulnerable areas from further rusting. The same chemistry underlies the commercial rust converter products sold in hardware stores, which the Wikipedia entry on rust converters confirms rely primarily on tannic acid reacting with iron oxide to form that same bluish-black ferric tannate layer, usually alongside a bonding polymer that seals the surface once the reaction is complete. Tannic acid itself is not a synthetic laboratory chemical. It is a naturally occurring compound, part of the tannin family, concentrated in oak bark and galls, chestnut wood, black tea, grape skins, and pomegranate rind. French chemist Henri Braconnot, working in Nancy in the early 1800s, spent decades studying exactly these kinds of plant compounds. He is credited with isolating gallic acid and ellagic acid from oak galls in the early 19th century, and his work, published in the Annales de Chimie, helped lay the groundwork for understanding tannins as a class of chemical compounds. The dark blue-black stain produced when a tannin infusion meets iron had actually been noted long before Braconnot's era. The Roman writer Pliny described it, and it was already used for ink and for testing mineral water by the 16th century. Rural households and blacksmiths who did not have access to laboratory chemistry could still use what grew around them. A strong brew of oak bark or black tea, applied to a rusted blade or hinge, does the same chemical job. Now here is the practical part, the actual method and what it costs. You need two things, a tannic acid source and a protective finish. For the tannic acid, you have two options depending on your budget. Food-grade tannic acid powder is available from bulk supplement retailers and lab supply sellers. A 100-gram bag typically costs $3 to $5 and, based on typical dilution rates and conservation use, can treat a substantial area of rusted metal. Enough for a full set of garden tools, several iron hinges, and cast iron cookware maintenance over a season. The Canadian Conservation Institute's own protocol recommends diluting a stock tannic acid solution down to a working strength of about 2% to 3% by weight before application, rather than using it at full concentration. The second option is strongly brewed black tea. Steep 4 to 6 tea bags in 2 cups of just boiled water for around 30 minutes until the liquid is dark and concentrated. Black tea contains meaningful amounts of tannic acid, though at a lower concentration than the pure powder. It works well on light surface rust on hand tools and costs almost nothing. Before applying either solution, use a wire brush or coarse steel wool to knock off any loose, flaking rust. Do not sand all the way down to bare, shiny metal. The tannic acid needs existing rust to react with. You are removing only the material that is already detached and is blocking contact, not the bonded rust layer underneath. That bonded layer is your raw material. Apply the solution evenly with a foam brush, cotton rag, or a piece of burlap. Within 10 to 15 minutes, you should start to see the surface darken. Orange-brown, shifting toward gray, then toward blue-black, as ferric tannate forms. Let the treated surface air dry fully, which typically takes a few hours depending on temperature and humidity, then apply a second coat. Conservation guidance is explicit on this point. Several thin coats of a dilute solution give a more even, better bonded result than one heavy, concentrated application. Once the final coat has cured, seal the surface. For hand tools, axes, hatchets, draw knives, fixed blade knives, A traditional finish is melted beeswax or boiled linseed oil, rubbed on with a cloth while the metal is slightly warm. Beeswax fills the pores of the converted surface and creates a flexible, renewable water barrier. Linseed oil polymerizes as it cures and forms a harder film. Conservators note, however, that tannic acid treatment on its own only slows re-rusting in the short term and works best as one part of a broader care routine. It is not a permanent one-time fix, and objects kept outdoors or in humid conditions will need reapplication over time. For cast iron cookware, apply the solution to rust spots. Let it convert and dry, then re-season the piece in a low oven as you normally would. The converted surface takes seasoning oil well. One thing worth knowing in advance, the finished surface does not look like paint. It looks like the metal has darkened, with a blue-black sheen in places and a flatter gray elsewhere. That color change is not cosmetic. It is the visible sign that the chemical conversion has actually taken place. Commercial rust converter products sold in hardware stores generally list tannic acid, or a combination of tannic and phosphoric acid, as their active ingredients, exactly as their published safety data sheets and the Wikipedia entry on rust converters describe. They typically add a bonding polymer and solvents to make the product easier to apply and to prepare the surface for paint. That added convenience is real, but the core active chemistry, tannic acid converting iron oxide into ferric tannate, is the same compound found naturally in oak bark and tea, and it can be sourced and mixed at home for a fraction of the price of a branded bottle. The broader point is simple. A rust-covered tool is not automatically a ruined one. Rust is a chemical state, and chemical states can be changed. With a few dollars of tannic acid, patience for a couple of coats to cure, and a proper protective finish afterward, tools that look far gone can often be brought back into working, protected condition, the same principle that lets museums and conservation labs keep genuinely old iron artifacts intact for display and long-term storage.